Okay, so one last problem for 4.6, just to make sure you've got enough practice. So I want to find the inverse given this function here. So I'm going to take my technique and replace f of x with y. So y equals x to the 3/5 minus 2, okay? And now after I replace f of x with y, I then swap my x and my y. So x equals y and then 3/5 minus 2. And now I want to solve for y. Okay, so the first thing I'm going to do is I'm going to add 2 to both sides. So when I do this, I get x plus 2 equals y to the 3/5. Okay, so there's a couple ways to do this, but one thing you might remember is the rider and the horsey example, okay? So the rider goes in the house and the horsey goes outside. So this is really equal to what? Well, the rider is in the house, the 3 goes in the house, and the horsey goes outside. So it's a 5th root of y cubed, okay? How do I get rid of a 5th root? Well, I raise both sides to the 5 power to get rid of that 5th root, okay? So the 5th root is getting rid of by raising it to the 5th power. Now, when I do that, I have a y cubed. Well, how do I get rid of a y cubed? Well, I've got a cube root, okay? If I cube root both sides, now all of a sudden I have y equals the cube root of x plus 2 all to the 5th here, okay? So last step, after I've solved for y, I replace y with f inverse. So f inverse of x is equal to the cube root of x plus 2 to the 5th power. Now, technically, I could rewrite this in rational exponent form. And what do we know? We know the rider goes on top and the horsey goes underneath. The rider's in the house and the horsey's outside. So really, you could rewrite this as f inverse of x equals parentheses x plus 2 close parentheses to the what? To the 3/5. Okay? So if you think about this, to undo an exponent, I'm sorry, this should be, I've reversed this. This should be raised to the 5/3. To get rid of y to the 3/5, I raised this, so doing it another way, if I had a 3/5 exponent, if I raise that to a 5/3 exponent, power to a power multiplies, and so that would cancel it out, and that's where that 5/3 is coming from right there. Okay.